At a basic level, the goal of every firm is to maximize profit. Granted, firms may have other tangential goals, but they probably still want to know how to maximize profit in order to analyze the trade-offs that they face between profit and other objectives. As you recall, profit is just equal to total revenue minus total cost. Or in other words, the total amount of dollars that a firm is bringing in sales minus the total number of dollars and other opportunity costs that it's paying out. So profit's just what's left over. Now, when we talked about total revenue before, we noticed that revenue was both a function of price and quantity. And obviously those two things are interrelated in large part. But usually when we think about maximizing profit, for reasons that'll become obvious later, we think about the firm as setting the quantity that maximizes the amount of profit that it gets. So all the decisions that we're dealing with here are going to be about choosing quantity rather than specifically choosing a price. The concept of profit maximization can be most easily introduced via an example. Suppose I gave you the following information regarding demand for a company's particular product and cost to produce a company's particular product. So what we see here is in order to sell 0 units, well, our price is sort of irrelevant in this case. If the firm wants to sell 1 unit of its product, it can set a price of $18 and still have one buyer for the product. If it wants to sell 2 units, it has to lower its price to $15. If it wants to sell 3 units, it has to lower its price to $12. If it wants to sell 4 units, it has to lower its price to $9. If it wants to sell 5 units, it has to lower its price to $6. And if it wants to sell 6 units, it has to lower its price to $3. This is just consistent with the concept of a downward sloping demand curve that we're assuming that this firm here faces. On the cost side, if a firm wants to produce 0 units, it's costing them $4. In this case, the $4 just represents the fixed cost of being in that industry in the first place, since we said that fixed costs are present even if the firm isn't actually producing any output. And we can see that it costs in total 6 units, or $6, to produce 1 unit. It costs $10 to produce 2 units. It costs $16 to produce 3 units. It costs a total of $24 to produce 4 units. A total of $34 to produce 5 units. And a total of $46 to produce 6 units. So just given this information regarding quantities, prices, and costs, we can go ahead and figure out what quantity of production actually maximizes this firm's profit. So you notice here I have a column that's currently blank that's labeled total revenue. And we said that total revenue is just price times quantity. For example, if I sell 3 units of output at $6 a piece, I've made $18 in revenue. So we can just calculate this total revenue by multiplying quantity times price. And we get, well, 0 times anything is just 0. So if you're not producing anything, you're not taking in any revenue. Selling 1 unit at $18 gets you $18 in revenue. Selling 2 units at $15 each gets you $30 in revenue. Selling 3 units at $12 each gets you $36 in revenue. Selling 4 units at $9 each also gets you $36 in revenue. Selling 5 units at $6 each gets you $30 in revenue. And selling 6 units at $3 each gets you $18 in revenue. Now we said here that profit was just equal to total revenue minus total cost. And now we have total revenue and total cost. So we can go ahead and calculate the profit generated by each quantity of output here. So here is 0 minus 4, which is negative 4. 18 minus 6 is 12. 30 minus 10 is 20. 36 minus 16, also 20. 36 minus 24 is in fact 12. 30 minus 34 is negative 4. And 18 minus 46 is, if I'm not mistaken, negative 28. Now what we see here is that we get increases in profit for a while, and then as we increase our quantity further, we're actually decreasing our profit and even getting into negative profit territory here. Negative profits are certainly possible if the cost of producing the output is less than the revenue that you took in from selling that output. And what we see here, if we're looking for the biggest numbers in our profit column, well, those happen to be these 20s here. And if we're just looking for what quantities maximize profit, well, it seems like based on our example here, that either setting a quantity of 2 units or 3 units is going to result in the largest possible profit. So one way that we could maximize profit is to just enumerate all the different possibilities and then pick the biggest profit number. But there's actually a mathematically more reasonable way to do this. To think about how to maximize profit, we could also think in terms of marginal revenue and marginal cost rather than total revenue and total cost. Just to review, marginal revenue is just the additional revenue we get per extra unit of output, or we can think of that as change in total revenue divided by change in quantity. Similarly, marginal cost is just the additional total cost we incur for each additional unit of output, and we can think of that as the change in total cost divided by the change in quantity. And we can go through here and we can calculate at each change in quantity, whether it be going from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and so on and so forth, we can calculate marginal revenue and marginal cost. So for example, on the marginal revenue side, if when we go from a quantity of 0 to a quantity of 1, our revenue goes from 0 to 18, then our change in total revenue divided by change in quantity is just 18 divided by 1, or 18. When I go from 1 unit to 2 units, my total revenue goes from 18 to 30. So again, my change in total revenue divided by change in quantity is just 30 minus 18, which is 12, divided by 2 minus 1, which is 1, or just 12. When I go from 2 units to 3 units, my change in total revenue, I go from 30 to 36, so I get a change of $6 for a 1 unit change in output. So in this case, marginal revenue is going to be 6 over 1, or 6. When I go from 3 units to 4 units, my total revenue doesn't change. It goes from 36 to 36. So my change in total revenue divided by change in quantity is just 0. When I go from producing 4 units to 5 units, my total revenue actually decreases. It goes from 36 to 30 for a difference of negative 6 units, since I decreased by 6 units. So in this case, my change in total revenue is just negative 6 divided by 1, or negative 6. And when I go from 5 units to 6 units, my total revenue goes from 30 to 18 for a loss of 12 units, in which case my change in total revenue divided by change in quantity is negative 12 divided by 1, or negative 12. You'll notice here that I put my marginal numbers sort of in between these two quantities, and some textbooks will do that, some textbooks won't. Sometimes the book will put this 18 in line with this first unit, since it's technically the marginal revenue associated with producing this first unit. They'll put the 12 with the 2, and so on and so forth. So sometimes you'll see these shifted down a little bit to correspond to these units. I put them in between the quantities just because it makes sense to some degree to say, well, if this is the marginal revenue in going from a production of 0 to a production of 1, well, to sort of put that in between the 0 and the 1. And we'll see how to deal with that graphically and whatnot later. In a similar way, we could go through and calculate marginal cost for each quantity of output. So the marginal cost incurred in going from a production of 0 to a production of 1, well, our total cost just goes from 4 to 6 for an increase of 6 minus 4, or 2. And our change in quantity, well, we just went from 0 to 1, so that's a change of 1 minus 0, which is 1. So in this case, our marginal cost is just this increase of 2 divided by 1, which is 2. In going from 1 unit to 2 units, our total cost goes from 6 to 10, which is an increase of 4. And our change in quantity is just 1, so our marginal cost is 4 divided by 1, or 4. In going from a quantity of 2 to a quantity of 3, our total cost increases from 10 to 16. This is an increase of 6 for a quantity increase of 1. So our marginal cost is just 6 divided by 1, or 6. In going from 3 units to 4 units, our total cost increases from 16 to 24, which is an increase of 8. Again, for a 1 unit change in quantity. So our marginal cost is just 8 divided by 1, which is 8. In going from a quantity of 4 to a quantity of 5, our total cost increases from 24 to 34, which is an increase of 10 for a 1 unit quantity increase. So our marginal cost is just 10 divided by 1, which is 10. In going from 5 units to 6 units, our total cost goes from 34 to 46, which is an increase of 12 for a 1 unit quantity increase. So then our marginal cost is just 12 divided by 1, which is 12. What you'll see here is that the marginal revenue and the marginal cost that corresponds to this profit maximizing quantity, or this set of profit maximizing quantities, are those which marginal revenue and marginal cost are the same. So notice it's right here that we'll see our profit is maximized at that point where marginal revenue equals marginal cost. And this is going to be an important rule for us to understand. Because what you can see here is if in going from production of 0 units to 1 unit, we got 18 additional dollars in, but only 2 additional dollars out, well, that means that producing this first unit added $16 to our profit. So we say, well, yeah, we want to produce that unit. It brought in more money than it cost us. Cool. Then we ask ourselves if we want to produce this second unit. We say, well, the second unit brought in 12 extra dollars and only cost us 4 extra dollars. So it actually added $8 to our profit. Adding things to profit is good. Yeah, we want to produce this second unit. Now when we get to this third unit here, we say, well, producing this third unit brought in $6 in revenue, but it also cost us $6 to make. Technically speaking, we're kind of indifferent as to whether or not we produce this third unit, but in most cases we just say, sure, why not? We'll produce this unit as long as marginal revenue is at least as big as marginal cost. And then we get to this fourth unit here. We say, well, this fourth unit doesn't actually add anything to our revenue, but it cost us an extra $8 to make. Well, clearly we're not going to want to make that unit, so we stop our production at a quantity of 3, which corresponds to this idea of profit maximization. And I know that this is a little bit confusing here in that we have 2 quantities that technically both give maximum profit, but this problem actually goes away when we stop thinking about discrete units of production and think about continuous cost curves instead. In general, we can say that when marginal revenue is greater than marginal cost, that our profit is increasing as a function of quantity. And that's simply because if marginal revenue is greater than marginal cost, then producing an extra unit will bring in more dollars than we have to pay out, so our profit is going to be bigger as we produce more units. On the other hand, if marginal revenue is less than marginal cost, then our profit is decreasing as a function of quantity. And again, hopefully that makes sense, because if marginal revenue is less than marginal cost, then by producing an extra unit, we're actually taking in less extra money than we're paying out extra. We say, well, that's not really worth it, because that's actually going to serve to lower our profits. If we put these things together, we see intuitively that we hit our maximum profit when this condition of marginal revenue being equal to marginal cost holds. And this is just a generalization of the example that we just worked through, because when we hit this condition of marginal revenue equaling marginal cost, then by producing that last unit, we took in exactly as many extra dollars as the extra dollars we paid out. If we were to think about this idea of marginal revenue versus marginal cost graphically, we'd get something that looks like the following. And this is just because as we produce more units, our marginal revenue tends to be a decreasing function of quantity. And as we said earlier in our cost curves discussion, marginal cost tends to increase as quantity increases. So we would see something here where marginal revenue is, sometimes it's flat, but it's either flat or decreasing in quantity, and marginal cost is generally increasing in quantity. So what we would see here is if we were to think about, well, do we want to produce this first unit here? Well, my marginal revenue, or the extra dollars from selling this unit, are all the way up here. The marginal cost is all the way down here. So yeah, selling that first unit seems like a pretty good idea. If I were to ask myself, do I want to produce this next unit? Well, the marginal revenue of producing that next unit wasn't quite as high as that for producing the first one. The second unit was more expensive to produce than the last one, but nonetheless, producing this second unit is still adding something to profit. It's adding exactly this amount to our profit. As long as it's adding something to our profit, it seems like a good idea. We could keep going with this line of reasoning. We could say that this unit here is still profitable to produce, this unit here is still profitable to produce, and so on and so forth. And we would eventually get to this point here, which is exactly our point where marginal revenue equals marginal cost. We'd say, okay, we've produced all these units that are profitable to produce, and we're going to stop here because any additional units cost more to produce than they bring in revenue. So you can see here how we're making that decision. At each step, we're thinking on the margin, as rational people in firms do, in order to figure out at each stage whether we want to produce one more unit, one more unit, one more unit. It's important to recognize that this Q star that I've labeled here, which turns out to be the profit maximizing quantity of output for this particular firm, it doesn't necessarily correspond to the quantity that gives the highest profit margin, the highest markup, or anything like that. In fact, we can see here that it was this first unit that has the highest profit margin or markup, since the difference between marginal revenue and marginal cost is biggest here, and that difference between marginal revenue and marginal cost keeps decreasing as we produce more output. Nonetheless, it makes sense to think about this as we want to produce all of the units that produce at least some positive or at least non-negative profit for the firm, because that's how we're actually going to get the maximum amount of profit. if I were to say, for example, oh, do you want to produce one more unit of output? It only adds $1 to your profit, whereas the first unit you produced added $10 to your profit. Well, you'd still say, well, $1 is more than 0, so I want to produce all of those units that actually add to my profit, which is exactly what we're showing here. For those of you that are using calculus to maximize profit, you'll notice that we actually reach the same conclusion as we did before when we think about how to maximize profit using derivatives. So again, profit is just equal to total revenue minus total cost. And in calculus, we say if we want to either maximize or minimize a quantity, what we do is we take the derivative and we set it equal to 0. In this particular case, we're choosing the quantity of output that maximizes profit. So we're going to be taking the derivative of total revenue and total cost with respect to quantity. So the derivative of total revenue is just derivative of total revenue with respect to quantity minus the derivative of total cost with respect to quantity. And again, we set that equal to 0. But what we'll notice, as we pointed out when we were introducing these different measures of cost, is that the derivative of total revenue with respect to quantity is just this concept of marginal revenue. Because this is really change in total revenue divided by change in quantity for very, very small changes in quantity. So it makes sense that this would correspond to marginal revenue. Similarly, the derivative of total cost with respect to quantity corresponds to our concept of marginal cost here, since the derivative of total cost with respect to quantity is just the change in total cost divided by the change in quantity for very small changes in quantity. And that's our idea of marginal cost as we defined earlier. Well, if we have that setting the derivative equal to 0 gives us 0 equals marginal revenue minus marginal cost, just a bit of algebra shows us that our profit is actually maximized when marginal revenue is equal to marginal cost.